So the question is, design a counter that counts the decimal digits according to 2421 code and use the T flip-flops. Okay, so we are going to design it. What is the first step in designing a counter? The first should draw the state diagram. And what is the second step? It is state table. And what is your third? You are going to get the Boolean expression, and you can simplify it using K-map or using LAS. And the fourth step is realization or implementation of the circuit. That is, you will be getting the circuit diagram here. So these are the design steps of the state diagram. So for that you need the code. So based on this code we can draw the state diagram. So it is starting from the 000. This is your first state. Then it is moving on to the second state, that is 0001. So it is flowing from the 000 to, it is flowing from the 0000 to 0001. So these two states are over. Now it has to flow to this next state. So the next state is 0010. Then it is flowing to the next state, that is 0011. From 0011 it is flowing to 0100. Then it is flowing to 1011. Then it is flowing to 1100. Then it is flowing to 1101. So from this 1101 it is going or moving on to 1110. Then from here it is going to 1111. 1111. So from 111 again it is going to the 0000 state. Okay. So this is your state diagram. So after drawing the state diagram, we have to move on to the state table. This is our second step. So the state table consists of the present state, then the next state, then the inputs of the flip-flops, flip-flop inputs. These things are represented in the state table. Okay, so now we go for it, and we keep this state diagram also by the side in order to refer it or for the ready reference. So here we have 4 bits values, right, for this 2421. So the present state, here we have to mention this is your present state. So that represents 4 bits. So you can mark it like A, B, C, D for the present state. Then for the next state, there also you can mark it like A, B, C, D, that 4-bit values. Then we have the inputs of the flip-flop, right? So that can be marked here, inputs of the flip-flop. So we can make it as TA, TB, TC and TD. So now we can easily fill up the table. So initially it is the first state is 0000 as the present state. So 0000 as the present state. Then it is moving on to the next state as 0001. Then when you have the present state as 0001, if this is your present state, then we'll be moving on to the 0010. If this is your present state 0010, then we'll be moving on to this 0011, the state. From the 0011 as the present state, next state will be 0100. So when you have the 0100 as the present state, we'll be moving on to this 1011 as the next state. Then when you have this 1011 as the present state, 1011 it will be moving on to 1100. From 1100 it flows to 1101. So if 1101 is the present state, it is moving on to 1110. If 1110 is the present state, next state will be 1111. So if 1111 is the present state, the next state will be 0000. Understood? So now we can form the inputs, that is T flip-flop inputs, right? So in order to get this T flip-flop input, you should know the excitation table of this T flip-flop. So what is excitation table? Well, for this T flip-flop. So excitation table means you will be given the present state and the next state. These are the outputs, right? And from that we need to find out the inputs. Okay, so what combinations are possible? We can have the combination like 00, 01, 10, 11. Okay, so this is your present state and this is your next state and T flip-flop input. So if you have this present state changed to this present state 0 is being returned as 0 in the next state, means the input must be the no change condition, so it should be 0. Whenever you get the present state 0 is changed to 1 as the next state, you must be having the toggle input. Okay, that is 1, t equal to 1. So whenever you have this 1 is changed to 0, again it is toggling, right? Present state is 1, next state is 0, so it is toggling or changing its state, means the t input must have been 1. And then whenever this present state is 1 and the next state is also 1, that indicates the t input is 0. So this excitation table you should know, then only you can identify the inputs. Okay, so we'll copy down. So now we keep the excitation table with us for the T flip-flop. Now you can refer each and every bit, compare each and every bit, and accordingly you can write the T input. Okay, so first how do you compare? Here you should have this 0 and this 0. Okay, these two bits must be verified. These two bits must be referred. And accordingly you have to fill up this. Okay. So here you have the 0 and 0 means that this must be 0. Okay. Then again here you refer this is 0, this is 0. So that indicates this combination, right? So that this is 0. Again 0 and 0. So you should know that there is no change condition. So toggle input is 0. And similarly here it is 0 and this is 1. So what is the condition here? 0 and 1 means the toggle input is 1. So like in this way we have to fill up all the columns. Okay, so you check here, this is 0 and 0, so no change, so it is 0, 0, and here it is 0, so it is 0. Then it is 0 and 1, so 0 and 1 means toggle, so it is 1. Then D is 1, D is 0 here, so 1 to 0 change, so it is a toggle. Then refer here, these two are 0. Okay, present state and the next state 0 for that particular A, so it is 0. It is 0 and 0 here, so no change, so it is 0. Then here it is 1 and 1, 1 and 1 also there is no change, that means the input is 0. Then here it is 0, here it is 1, 0 and 1 condition is again here, that is indicating the toggle condition, so 1. Again going for this 0 and 0, so you get it as 0. Then 0 and 1, so it is toggling or changing its state, so it is 1. 1 and then 0 for the C state, so it is changing its state, so it is 1. Then this is 1 and this is 0 for the D, so it is changing, means it is toggling, so it is 1. Then this is 0 and here it is 1, so changing means it is 1. 1 and 0 for B state. So it is toggling, so 1. It is 0 and 1. So that indicates toggling, so it is 1. 0 and 1 here. That indicates again toggling, so 1. Then go for here 1 and 1 for A state, no change condition, so it is 0. 0 and 1 for B state, so it is toggling, so it is 1. 1 and 0, it is toggling, so it is 1. 1 and 0, it is toggling, so the input is 1. Then here 1 1, so it is 0 1 1, so again it is 0. Here it is 0 and 0 for C state, so no change, so it is 0. 0 and 1, it is toggling, so it is 1. Then here it is 1 1, so it is 1 1 1, so it is 0. Then 1 1 here, so again it is 0, no change condition. 0 and 1 here, so it is toggling 1. And it is 1 and 0, it is toggling again, so you get a 1 here. Then here it is 1 and then here it is 1. 1 1, no change, so 0. 1 and 1 here, so no change, so it is 0. 1 and 1 here, there is no change, so it is 0. 0 and 1, it is changing, that means it is toggling, so input is 1. Then here 1 and 0, so 1 and 0 means toggling, so it is 1. 1 and 0, it is toggling, so it is 1. 1 and 0 for C, so it is toggling, so it is 1. Finally it is 1 and 0, so it is toggling, so it is 1. So in this way we have filled up all this T inputs, TA, TB, TC and TD. So after filling up this table, the next step is to have Boolean expression, isn't it? That is your third step. So that Boolean expression can be obtained using K-map. So we have to obtain the Boolean expression for this TA, TB, TC and TD separately. So first we are going to have the K-map for this TA. It is a 4 variable, right? A, B, C, D. So we must have this 4 variable K-map. So we are going to draw it. So we are going to have this TA. So refer this TA alone now. This one, right? Refer this alone, this column alone. So where do you get the ones here? So here you have a 1. So we refer this. So this one corresponds to the 0100 combination. 0100 is this one. Similarly, this one that corresponds to 1 1. Then 11, 12, 13, 14, 15 alone are available as decimal digits for this case of 2421 code. So the remaining values like 5, 6, 7, 8, 9, 10 will be considered as don't cares. So on that cases, we have to mark the don't care conditions as X. Okay. So 5, 6, 7, 8, 9 and then 10. So after marking this don't care, we can group them. So you can mark the grouping like this. These things can be combined once along with the X's. And you can now write the expression. This corresponds to this one as well as these values, right? So here everything get cancelled, and on this side alone you are getting this is A bar B, right? This corresponds to A bar B. So your expression for this case is A bar B. And then here you go for this case combining these two because of this one, and you can write the expression here. This corresponds to this, and on this side these two will be covered. So this 0 and 1, it is varying, so it is getting cancelled, but this 1 remains unchanged, so you can write it as B, and here we get this as C and D. So the answer for this TA is or the expression for this TA is A bar B plus BCD. In this case, we can write it like taking B outside, this A bar plus CD. Okay. So we got the expression for this TA. In a similar way, we can do it for TB. 11, 12, 11, 12, 13, 15 and 15. Okay. Now, this is the K-map for TB, right? So we refer this particular column, that is TB column alone, we are going to refer. So on this case, we have the ones here. 4 ones are available. So this one corresponds to 3. So mark a 1 here. For this, it is 4. So mark a 1 here. Then this corresponds to 11. So here you mark a 1. And then this corresponds to 15. Mark a 1 here. So we already know that the don't care conditions are 5, 6, 7, 8, 9 and then 10. These are don't cares. So we mark the don't cares here. 5, 6, 7, 8, 9 and then 10. Okay. Now, how do you mark this? This can be marked like this. 1 along with x, 1 can be combined, and for this you get the answer like on this side everything get cancelled. And here this 1 is available, that corresponds to C. Similarly here, this 1 can be combined along with the 3 number of x's. So you can write the expression like on this side these get cancelled, right? And here you get this on the side, that corresponds to A bar B. So the expression for TB is equal to CD plus A bar B. You can write it like A bar B plus CD, right? So this is the expression for TB. So now we are going to draw the K-map for TC. So we will consider this particular column in which these ones are available. Okay. So corresponding to this, we have the 1 here marked with the 1. Then this corresponds to 3. And then this corresponds to 4. And then we have 11. We have 13 and then 15. 11, 13 and 15. And we already know the don't cares of 5, 6, 7, 8, 9 and then 10. Okay. Now we can combine this 8 number of cells together. And here these get cancelled, right? And on this side you have these two, and this 0 and 1 is changing, so only the D remains unchanged. Therefore the expression here is for this particular loop is D. This 1 is left over, right? That can be combined here like this along with this x's. So you'll be getting this S. This can be written here using A bar B. On this horizontal side everything get cancelled, right? So the K mark for TC, so the expression for TC is equal to A bar B plus D. So now we can draw the K map. We have drawn the K map, and this K map is to find the Boolean expression for this TD, right? So we consider this particular column here. We have the ones here. Everything is 1, right? Good. So everything is 1 means the 0, 1, 2, 3, 4, right? And then 11, 12, 11, 12, 13, 14, 15. Anyhow, the remaining will be don't care. So all the 16 cells are filled up. So you can mark the complete thing. so that you will be getting it as a 1. So TD is equal to 1. Right? So we got the expressions, Boolean expressions. We can combine them now. So it is initially TA, it is B into A bar plus CD. Then we go for this TB, it is A bar B plus CD. TC is A bar B plus D, and TD is equal to 1. So using this expressions we can now go for the circuit implementation. So this is your last step, circuit diagram. First we draw all the flip-flops. So this is a T flip-flop, T input, and this is A output. This is your T flip-flop. Then we have the clock. Similarly you can draw the B flip-flop. So here you can mark it as TB, and here it is B, the output. You can also mark it as B, A bar and B bar with the clock input here. So now we are going to realize the circuit diagram for the Boolean expressions which we have obtained. So we have this expression. For this expression we can implement it. So first you can take, or you can implement this A bar plus CD, right? So C and D, for that we can take the connection from here, the C, you put the line here. For D also you put the line here. So for this we can have a common line for this C. So I'm going to use different colors here. So for D we can use the blue color. So we can mark this, the whole line is D, and then I go for this green to mention the B. To take this here to here also, you can, if you want, you can take it, right? Then this black color, that is for this A, right? So like this you can draw the lines. Then it is C and D, right? In order to give it to A, and so take the connection from this C and D. C is red color, so take the connection from here. D is from here, right? Blue color. So you have to combine these two using AND gates. Then it must be combined with the A, right? A is this black, A bar you need, right? Take the connection from here A, give it to an inverter. So that must be combined with this. Okay, these two given to an OR gate. They must be given to OR gates. So if you want to do it very neatly, first you can implement it something like this. First C and D, right? And then it must be combined with this A bar, right? It must be combined with the A bar. So that is given to an OR gate. Then you have the connection from this B. They must be combined using the AND gate again. So this is the actual circuit diagram we need, right? So after having this, I'm going to have this. So I can actually tilt this. So after marking all the lines, I'm going to insert this particular, okay, which corresponds to, already I have told you that this is like CD, okay. So we can insert it here. So we know that this corresponds to D, this one is C, and this green color represents your B, and this black is A, right? So I want to combine here, this corresponds to C and D. So you can take this as C and this is D, means you can make the connections out of this. So C comes from here, right? Okay. Then it is A bar, so I am taking the connection from here. We have to mark it here like this. Okay, then this one is from this B, right? So we can give the connection here to this one. So this output will be given to this TA, okay? So the clock, all the clocks can be combined so that we have the synchronous clock. We can have the common connection out of this, this, and then this. This is positive triggering. This is your common clock. Now look at this TB. TB is A bar B plus CD. So we can mark it like this. First you make the connections C and D. They can be combined like this. Similarly, you can have the combination from this A bar and then this B. They can be combined. This is C and D. This is A bar A B. Then A bar B. It is coming. Then they can be odd. Okay. Then it can be given to this TB. So I am taking this completely. Okay. So we can have this in between. So we want to mention it for this TB, right? Here we can include it like this circuit diagram. Then you can make the connections here. So this is from C. So we can take it from here. Then D connection. So it is from here. You can mark it. Then for B, the color is green. So I am taking the connection from here. And then it is A. So I'm taking the connection from here. Okay. After that, for this TV, I can give it to this one. Okay. So the input is now over. Then go for the next one, that is TC. TC is, we take the connection from this. It is A bar. So A. Then B, we take the connection. They are given to AND gates. Then the D is taken. This is B, right? D is taken. These two are combined using the OR gate, right? Then you get the output here. So I'm going to take this. Okay. So we can include this particular diagram here so that we'll be getting this TC. So first one is A, that is black color, right? So we give the connection from here. Then for the B, it is green color. Take the connection out of here and combine it. And D is blue color, right? So I take the connection from here and we can mark it. Now you can give it to this red color input. So it is for C. Then TD is 1, right? TD it is 1. So simply you take the connection of this and always it should be equal to 1. This value. Okay. So in this way we got this circuit diagram being implemented. Okay, this is your circuit diagram. Hope you have understood. Thank you.